the second type of hypothesis testing using the t-test. And when do we use the t-test? We use the t-test when the sigmas are unknown, okay? Unknown. So as we said, when you have the population standard deviations known, then we use the z-test. When the populations standard deviation are unknown, we use the z-test. And as we mentioned before, we are going to have two cases. The case number one, we are assuming these standard deviation equal. And the second scenario is going to be when these standard deviation, we don't assume them to be equal, right? So there are assumptions to use this method. Before we go and solve the question, we have to make sure that these checklists are already met, okay? So the populations, both of them have to be normally distributed populations. Number two, the variances have to be equal, or the standard deviation. These are the variances again. Both samples have to be independent. Both samples have to be independent. So we are going to look at set of data now. This is an example. And we'll be doing this using Minitab. And by the way, this is the formula of finding the t-value. This is the degree of freedom that we used to talk about. And the SP, we call it pooled standard deviation. And this is taken already from the previous formula that we have shown. So if you go back, you're going to see it there. But we'll not do any kind of manual calculations. Excel has a procedure for performing the necessary calculations in this type of testing. We will not do this. We will not use Excel, basically. We will be using the Minitab. So consider the example is, consider a national car rental company that is interested in testing whether there is a difference in mean mileage for a sport utility SUV driven in town versus those driven on the highway. So we are comparing two things, the mean mileage for the SUVs driven in town versus the mean mileage for the SUV driven on the highway, right? So we will have the data. So the company believes that the mean highway mileage will exceed the mean city mileage. This is my alternative hypothesis. So let's build this here quickly. So my null hypothesis is the mu1 is less than or equal to mu2. The alternative, they are saying that mu1 is greater than mu2. Okay, mu1 is the first one. Basically, mu2 is the second one. So mu1 is the mean of the highway mileage, and the other one is the city mileage. So you can again write this in other ways. We can write this like this: mu1 less than 0, mu1 minus mu2 is greater than 0. Again, what is the mu1? Is the mean highway mileage. So this is my mu1. Mu2 is the mean city mileage. This is my mu2. Okay. So what I'm going to do, I'm going to go to Excel, to the Minitab and get the data and put them in Minitab and try to solve the problem. So this is my thing. But let's just continue the question. Test the belief they selected 25 SUVs driven only on the highway and another random sample. We have two samples. So they are taken from two different populations. The first one, they're taken from SUVs driven on the highway. The other one, 25 SUVs driven only in the city. They are independent sample. So this is the first thing that we have to notice. They are independent samples. Independent because they do not impact. The first one doesn't impact the influence, or it doesn't influence the occurrence of the second one. The occurrence of the first one doesn't impact the occurrence of the second one. The vehicles were filled with 14 gallons of gasoline, etc. Yeah, I mean, this is the kind of a thing that they have done, but at least we know the sample size, and we don't know the standard deviation. We don't know the standard deviation of the populations. It's not given to us. And we are going to assume that we have equal variances, and we are going to assume that the populations are normal. Actually, you can do some little things. Let me show to you how to make sure that the other two assumptions are met. So let's go to Minitab. Okay, we said that we have the list of the data. So let's look at the data we have. So these are the mileage, the 15 or 25 vehicles were taken from different populations. And these are the mileage on the highway. And these are the mileage for the city, inside the city. And these are in Excel. So what I'm going to copy these, and I'm going to go to Minitab and choose the first two columns and paste. Just Control V or Command V. So I pasted my data here. Again, we have to make sure that three assumptions are met. Usually the question gives you this, so don't worry about these because in Chapter 11 we have more details. But we have to tell this. We have to mention that in our report that The samples are independent. We mentioned the reason. The second thing, the populations are taken from normally distributed or normal distribution. Both of the populations are normally distributed. And the third one is we are assuming the variances or the standard deviations of the populations are equal. Basically, we can just have a quick look. If you select the stat, basic statistics, and the graphical summary, if you choose both of them, let me just deselect these. If you select this one here, you select the other one here, and you said confidence level, that's fine, it's not important now, equal. But if you look at the box plot, it looks kind of normal. It looks normal. Why it's normal? Because the median is in the middle of the box. These two whiskers are not that, they have the same length almost, so we can say it's approximately normal. The same thing is applicable to the second one, which is this one is the mileage, the city mileage. The other one is the highway mileage. So the city mileage, we have almost the same. Okay, this one's a bit shorter than that one. That's okay. Approximately normal. Then I mean, this is good. It's not bad. So we can assume that these are normally distributed populations. We can do more, let's say, in-depth search, and we can tell from these skewness and Curtis's values, both of them are approximately, close to the zeros, and the same is applicable to that one. So we have kind of normally distributed, and we will be assuming the equal variances unless the question mentions otherwise. Okay. So this is just a quick things you may do. But now let's look at the question and do the t-test for that one. So we're going to do the t-test because the population standard deviation is not known, okay? So two sample t-tests. Both samples are in one column? No, we have two columns, basically. So we're going to choose sample one. It's going to be, sample one we said is the mileage or the highway mileage, or which one we said in the other video? Yeah, highway mileage, the mu1. Mu2 is going to be my city mileage options. The confidence level, we're going to use 95%. And the hypothesized difference is 0. The difference between the mu1 and the mu2 is 0. The alternative hypothesis, what did we say about that one? We said mu1 is greater than the mu2. Well, basically the difference, the difference is greater than the hypothesized difference, which is 0. Yes, this is the alternative hypothesis. Assume equal variances, yes. Okay. Then you look at the data. So what do we find here? The first one gives you descriptive statistics about the standard deviation, mean, etc. And the second one gives you the estimation for the difference. The difference is 1.18 this is the lower bound, based on 95% confidence level, but we look at the test values, the p-value basically. So the p-value is what? It's a one-tailed test, number one. It's a one-tailed test, right? It's a one-tailed test. And the p-value is 0.007, which is less than the alpha. Alpha is 0.05. So in this case, if the p-value is too small, then what we do, we reject the null hypothesis. We reject the null hypothesis. And the sample data provide sufficient evidence to conclude that the mean SUV highway mileage exceeds the mean SUV city mileage. And this makes sense, basically. And it matches our beliefs, basically. And this study confirms the expectation of the rental company managers, right? So this is so the factor, and this will be factor into the company's fuel pricing, basically. So we are rejecting because p-value is less than alpha, right? So that means we're accepting the alternative hypothesis that, oh, there's a difference, basically. The highway is greater than this is greater than that one, right? So this is the solution for that question. So we have to write this down, the thing that I have said. Another example, again, we are using the z-test, the t-test, when both sigmas are unknown, and again we assume that both sigmas are equal. Sigmas or sigma squares, the variances. So this question is about the one that we did already in the estimation of the populations, the confidence interval. We are continuing this one, and we are doing the what? We are doing the hypothesis testing now. The two plans that we have, the retirements plans, right? The programs. And we have these two from the previous, just refer to the previous videos that we made about the estimation of the hypotheses of the confidence interval, sorry. And now we will be doing the hypothesis testing and performing the hypothesis testing, because we took two samples, each 15, and we found that the x-bar for each of them is this, and the standard deviation for the sample is this. So we are given the standard deviation for the samples, not for the populations, right? So we need to make sure that, the different plans, they have difference. There is a difference, or there is no difference between these two plans. So what we are going to do using the alpha equals 0.05, we're going to go to Minitab again. So we are going to go to stat again, basic statistics, two-sample t-test. Then we will not choose the columns because we have the summarized data. And basically we did this before, but what we're going to add today is the hypothesis testing. The sample size 15 for each. The sample mean for each is 2,119.7. The other one is 1,777.7. And the standard deviation of the samples is 709.7. The other one is 593.9. Then options, we have 95% confidence level correct. The hypothesized difference, we are assuming that is 0. The difference is not equal to the hypothesized difference. This is the alternative hypothesis, right? We have two tests in this case. Assume equal variances, yes, unless mentioned otherwise. Equal. Then we go and look at the p-value. The p-value is what? The p-value is 0.16, which is greater than what? It's a greater than 0.05, the alpha. So we are not locating on the rejection region, right? Excuse me. So we are not located in the rejection region. So what we do, we fail to reject the null hypothesis, right? So the difference between the two means is actually due to the sampling error. It's not actual difference, basically. Because there's no statistical significance, there's no statistical justification to believe that the mean annual investment in the first plan, TSA option, is different from those individuals eligible for the other plan. So again, there is no evidence, there's no statistical evidence, there's no sufficient evidence to support or to believe that the first plan is different from the second plan. So that's why we fail to reject the null hypothesis. We fail to reject this fact. We fail to reject this fact, so that if we find a difference in the sample, if we find the difference, which is already, if you look at the sample, there's a difference in the mean, but this is due to the error, due to the sampling error. 95%, we don't have a difference, and basically we confirmed this from the beginning. If we look at the 9 and 5 confidence level interval, which contains the 0, so there's no difference basically. Or there's no, let's say there's no statistical evidence, or there's no sufficient evidence to conclude that they are different. They are not maybe. So this is the second example. The last scenario that I'm going to discuss here quickly without giving an example. If the question asks you just to do if you are given two populations, but you don't know the standard deviation of the two populations, then you have to do the two sample. But you are going to use this one because if you have two samples taken from two different independent, these are two independent samples, then you have to do that one. The only thing that you have to make sure that if we don't assume an equal variance, then you have to take this off. So if the question asks you, said, oh, but we do not assume, we are not willing to assume that we have equal variances, then you have to take this one off. This is the only thing that you have to do. There is a kind of a difference in terms of the formulas, especially with the degree of freedom for the t-test. But again, because we don't do manual calculations, then what you have to do is just take this off.